Hello and welcome to the channel again. I know it has been quite some time since my last video and my apologies for that. Today, this video is going to be a special one, at least for me, because it's about something that has been my dream for quite a long time. Since my initial days in computing, which is well over 2 decades now, that I have been dreaming about custom liquid cooling my PC. Now, and in those times in India, it was very difficult. First of all, there was nothing that was available here in India, or that you could even mod to do something about it. And at that time, it was prohibitively expensive as well, especially for a student. Now, there are, things are getting better. Situation is improving in the case of availability of components for liquid cooling. However, it is still an expensive proposition. So, what I'm going to do is, in this video, I'm going to take you through the steps of the particular subject that we're talking about. I'm going to take you through the subject itself. I'm going to help you by listing out certain steps. First is obviously, what is liquid cooling, how to do liquid cooling, what are the different components, how many of each component was required in my setup, which may help you to understand and design your setup. What are the possible issues that may present themselves, and what are the processes that you need to do before and after. So let's get on to it. So what I'm going to do is give a brief understanding of the subject itself, and then list out the steps that I took and what I did for the for my setup. So the first thing that we need to do is understand the topic and subject of liquid cooling. What is liquid cooling? Liquid cooling, as the name suggests, is harnessing the cooling capacity of a liquid running through a system to cool down the various components. And to understand it, or to understand better, you can equate it to how we have our cars and some of the liquid cooled bikes cooled down, the engine cooled down by coolants, liquid coolants, right? So basically there are coolants that are running through the engine, cooling down or basically absorbing the heat of the engine, going through the radiator, getting cooled down themselves and then coming back. There's a whole loop towards it, right? They go round and round. Similarly, in computing, you can harness the specific coolants and their coolants properties to cool down the various components of a PC. Primarily, the processor itself. So there are various kinds of liquid cooling as well. That's a simple brief of it, right? And there are various kinds of liquid cooling as well. So one is a closed loop. A loop basically means the same thing, right? The liquid runs through a loop from the heated component or the hot component to a radiator to get cooled down, and then back to the hot component. So it'll go in a loop. So there is something called a closed loop, and we have all-in-ones in the market, AIOs as they are called. So which basically means that there is a water block for the component. So in this case, normally you have CPU water blocks connected with pipes to the radiator, on which you can install fans and then install it directly in your PC. So all you have to do is just put on the water block onto the CPU, onto the processor, install the radiator, install the fans, and there you go. You don't have to do anything extra because the loop is already there, the pipes are already there, the coolant is already there, the radiator is already there, everything is connected. You cannot open them, and hence the name closed loop. There are certain closed loops available for the GPU also, but I don't see that much in the Indian market. Then there are custom loops, as they're called, or open loops. What it means is basically that you have the various components of the water block that you need to cool down the component, basically attached to the component, the pipes, the radiators. They're all separate. You can buy each and every component of the loop according to your wishes, according to your design, and build the custom loop. Hence the name open loop and custom loop. So one of those components is also very important in the sense that it would mean being a little easier to work with, a little harder to work with, which are the pipes that connect the blocks to the radiators that transfer the coolant within the system, within the loop. The pipes come in two forms. One is a flexible pipe or a soft tube, as they're called, and another a hard tube. Basically, again, a hard tube is something that you cannot bend. They're not soft, they're not flexible. Hard tubing also come in two types. There are more types of hard tubes, but primarily two types. One is PETG, which is a plastic, and one is acrylic. Both have different properties. PETG is harder to break, but easier to scratch. Acrylic is harder to scratch, easy to break. Deciding what you need to do, whether you want to go closed loop or open loop. If you want to go for open loop, that is where our conversation begins. You need to find out, or basically you need to design your own loop. That is the basis. The design of your own loop is the basis for all your decisions going forward here. Based on your case, based on your cabinet, based on how you want to, or based on how the layout is, you will be designing your loop. There are various things that you have to take into consideration as to where is your radiator going to be, where is your pump and reservoir going to be, which positions are your processor or are your components going to be. There is also the possibility of cooling other components in your system other than the processor. So one of the other main components that needs to be cooled down is the graphics card, because usually the two most hot components within your PC are the processor and the GPU. So along with the processor, you can choose to cool down your GPU as well. And if you want, you can cool down your motherboard, VRM, your motherboard chipset, and so on. It depends on what you want to do. Also, you can choose to have multiple loops within your system. For example, you can have one loop cooling down your CPU, another loop cooling down your GPU. The thought behind it may be that you don't want to mix the two loops together so that each have optimal cooling. But in my opinion, in many cases, in most cases, it doesn't matter as much, and it may vary to probably 2 or 3 degrees. Again, I'm not the expert. You can probably look up other references on the internet. Once you have decided on these things, once you have designed based on your case, that's when you know what kind of components you require and how many of those components you require. For example, in my case, I have the Thermaltake, the Tower 900, which is a humongous case. It is as big as a small fridge or refrigerator. And, what I did was I sat down, I basically tried to see if there are 3D models of the case available anywhere, which I can use to create 3D models of the design that I wanted to have. Ultimately, I was not able to find, and I did not have probably the technical or the graphical acumen to design in 3D. So what I did was, back to the basics, pen and paper. I started measuring everything. I knew the dimensions of the case. I started measuring everything through a scale, put it down on paper, started designing how it should be, what should be the length, where does it turn, where does it bend, and all those things. Remember, hard tubes are not flexible. You have to heat them with a heat gun and make them flexible, make them malleable so that you can bend them. So that is where one of the complexities arises when you're designing a custom loop with hard tube. See, mistakes happen. So anyway, so you'll have to design those pieces as well. If you do not want to bend it yourself, what you can do is invest in components which can help you bend the loop itself. So you don't have to bend the tubing themselves. You can invest in components like connectors, 90-degree connectors, 45-degree connectors, to connect in between so that you can route the coolant whichever way you want. Something like this. So this is a 45-degree connector which you can connect. You can connect another pipe here, so you don't have to bend the pipe. This itself routes the cable along the angle you want. This is, by the way, a Thermaltake double compression 45-degree fitting or connector. And a double compression basically means that it compresses the tube on both sides, right? So it holds on. But there is a flaw, I believe, although it's going on still all right in my system, fingers crossed. But these connectors don't necessarily grab on and hold on to the tubes. And if you pull them, they come out. Well, I think we are getting ahead of ourselves. So my design of the loop was basically a serial loop. I was going to be cooling the CPU, the motherboard VRMs, the GPU, which would then go to the radiator, get cooled down, come back to the pump reservoir, and then roll loop again. Now, as I said, based on your design, that's where you will find out what components you require and how many of those components you require as well. For example, I decided to go in a little more, so I calculated. For example, I decided that this is my design, this is where the bends are going to be, this is where the pump reservoir is going to be, and this is how it is going to go to the CPU first, and then to the motherboard, and then to the GPU, and then to the radiator. So these are all the places that the bends would be. And if I am not able to do bends, I bought a little extra. So I bought these 90° and the 45° fittings, connectors, extra. And I calculated, right? So these are the number of bends and these are the number of fittings that I have made. Similarly, you would need the number of compression fittings that you would attach to the tube and to the component itself, the component being cooled. So, for example, I needed 2 compression fittings, and what I mean by compression fittings are these. These are the compression fittings. So basically they'll screw on. Now these screws are standards. They're standard G1/4 or BSPP 1/4. So they are so basically all the motherboard VRM water block that I had, they're also based on G1/4. They're basically the threads, right? And the water block, basically the liquid cooling kit that I bought, the Thermaltake CL360 Max D5, also are all based on G1/4. So I had, what I did was I bought the compression fittings, which obviously these are the threads, and the compression fittings basically are the preferred fittings, where because they would be they'll be holding on tight to the component and to the tube, and also they'll prevent leakage with the O-rings inside them. So the compression fittings are basically, if you see, they would have these outer layer, then you have this itself, and then this particular piece, and then the O-ring. So once you have been able to understand how many of each component you require, you'll be able to define and buy accordingly. Because I bought a kit, I knew that I was getting, let's say, 6 compression fittings. I was getting 2 90-degree connectors, so I would probably require a little bit more of each. I also was going after a theme, and based on that I required separate colors, so I bought accordingly. I bought the red compression fittings accordingly. So again, it depends on your budget, it depends on your design. You'll have to get that figured. Now, as you will see from the video, you will have all of these components. So you will have a CPU water block, which will basically be attached on the CPU itself, which will cool down the CPU by routing the liquid coolant through. You will have a GPU water block if you want the GPU to be cooled. You may have an installed water block already on your VRMs, or you can buy them separately. You may have a chipset, motherboard chipset water block. You will have your compression fittings. You will have your compression connectors, 90-degree. You will have your extenders, which can extend based on how you want to design. Maybe the pipes are not long enough, or maybe you want to adjoin 2 different pipes. Your pipes, there will be your coolants. Again, depending on the coolant, the compatibility is very important, because certain coolants may not be compatible with certain tubings, and in fact within PETG as well, certain coolants may not be compatible with certain manufacturers' PETG tubings. It requires quite a lot of distilled water so that you can not only rinse and clean the water blocks radiators, but also run through the distilled water once before actually filling the coolant. And depending on the length of your loop, the size of your loop, the size of your case, the quantity of distilled water may vary. And if you are going for hard tubing, you will have bending kits, which would include the cutter, where you will be cutting the PETG tubes or the acrylic tubes. You would need these silicone insert, because if you do not use a silicone insert, you will have issues while bending them through heat. Crimping of the tubing may occur, breakage of the tubing may occur, so you will need the silicone insert. And the size of silicone insert also, multiple sizes are available, depending on whether you have 500 mm tubings or 1 meter tubings. You will also probably require mandrels, depends on your expertise. In my case, I started using mandrels, but I found that in fact hand bending was far more easier and accurate for me. Now for the preparation piece, where you would be cleaning and rinsing and bending the tubes. Have distilled water ready. I would say be safe. Have around 10 liters of distilled water ready with you, because it can take some more depending on how you want to rinse and clean. You need a bowl with soap water. You need a heat gun, preferably with temperature control. I bought a DeWalt heat gun with temperature control, where I was able to accurately increase the temperature accordingly, and found out that I was able to bend the tubes based on a particular temperature setting. You may also want heat resistant gloves, and depending on how comfortable are you using the heat gun to bend the tubes. Be careful, you may hurt yourself, you may burn your hands. So maybe investing in heat resistant gloves may be a good idea as well for you. The next step would be for you to clean the radiator. I did was also not only distilled water. What I did later was basically take some RO water, warmed it a little bit, put it in the radiator, and shook them quite a bit, flushed them out, repeated the process for certain times, so a certain number of times. And then after that I used distilled water again with the same process, repeated that for again a few more times, and then dried it. Now, as I was mentioning, that the next step would be, obviously you can do the same things with your CPU blocks and the GPU blocks, right? You have to clean them up with your distilled water as well. It's better to do that because, again, as I said, there might be certain impurities, certain gunk resident within those blocks as well, and it will help that you clean them out now rather than later. The next step would be to bend the tubes. If you are into that, bend the tubes as per your design. As I said, keep the case in front of you and carry on with your bending process. Remember to use soap water. So basically, why it will be used? Because you will need to dip the silicone insert into the soap water completely, and then push the silicone insert inside the tube while bending it, while heating it up. The reason is, not only does it go inside well, it also can come outside. Otherwise, if you do not use soap water, the silicone insert may be trapped inside, and you may have to cut up the tube again to take out the silicone insert. So remember to use the soap water. Now, in case of PETG tubes, the PETG tubes start getting malleable around 60 degrees Celsius, and after that you will have to experiment, at which point you will be comfortable rotating them and bending them at what temperature. For me, it was around 170 degrees Celsius for around 2 to 4 minutes. And remember to heat up a greater length of the tube for you to bend that particular position. If you are bending it, for example, if you're going to bend it here, you make sure that you heat. If you're going to bend it here, for example, you have to make sure that you heat the entire length here, just to make sure that you are able to bend it appropriately and there's no crimping in the process. If you only bend it here, there might be crimping in the tube and it will not bend properly. So you may lose the function of the tube itself. Once you are done with the bending, let's say of a particular pipe, check it in the case. Sorry. So check it in the case and see if it is aligning properly as per your design. Remember to basically have the fittings on the components themselves so that you can check it, connecting it seeing if the bend is appropriate or not. Now remember, what I found out is certain bends you can actually, if you did not bend it properly, not appropriately, you may be able to re-bend it if you heat them appropriately and then come back and do it again. So you should be able to do that as well. Just make sure that you look at the tubing and make sure that there is no scrunching, there's no crimping, there are no other marks than on the tube, and ensure that the tubes are okay enough. And remember, as I said, when checking them, right, it's essential to check them in the case. If you do not do, at a later point of time, you may find out that it doesn't fit, and it will be a problem at that point of time, right, when you are finished with it. So it is always better to check it as you are doing it. And remember, it is easier to err at this point of time rather than later. One more thing that you have to consider is always work with a longer piece of tube, so that even if you have a mistake or error in the bending of the tube, you can always cut it. But you cannot make a shorter tube longer, right? So always have a longer tube available with you. What I did was, at the beginning, I knew that I would be getting 8 pieces of 500 mm tubes with the liquid cooling kit. I bought some extra tubes as well. So Thermaltake has these BTG tubes in 1 meter packs of 4 each, 4 1 meter tubes in a pack. So you can buy that and maybe practice with one of them before you actually go down and do the actual bending. And as I said, after you're done, make sure that you are able to fit everything in place. Everything gets, you're able to connect everything. Once you're done connecting everything, you next use distilled water to fill in the loop. Now, filling in the loop can be done through some bottles that have this attachment where you it's like a pump, so you can pump in water, or you can buy a separate funnel that has a G.1/4 connector which you connect it on top of the pump and then fill in water through that, which I used. And as I was saying, you fill it with distilled water. The distilled water is used to not only clean the system again, but also to check for leaks. So what I did was, I also used something, I also used Sysprep, premature Sysprep. Basically use the cleaning agent's instructions along with it. And so what the instructions for this was around a gallon of distilled water, and mix it with this particular bottle, and then fill in the loop. So that's what I did. The loop took around 1.25 liters of water, distilled water. Then I ran the loop for around 1.5 days and then drained it. Now remember, one thing I forgot to tell you. Do remember to buy a drainage valve. It's one of the most important components. A drainage valve, and make sure to design your loop in such a way that your drainage valve is connected to the lowest point in the loop, so that you can drain your loop effectively. And you will use paper towels. There are other ways of checking for leaks as well. The most common one is using paper towels and putting it in places, specifically the areas where you connect things together, so that if you have leaks, you know that immediately know that there are leaks based on paper towels, and you stop the loop at that point of time itself. Now remember, while filling in, never run the pump dry. You have to start the pump, fill in the pump with distilled water or coolant. start the pump, stop the pump before it becomes empty, refill it again, and continue the process until the loop completes. You have water coming back from the loop to your pump, and the pump reservoir now has more water than air. After making sure that your distilled water is mixed with the cleaning agent, you have to make sure that you disconnect all power from everywhere in your system if your system is already built. And if you're assembling it yourself now, then do not connect power anywhere. Make sure that you connect the bridging plug into the 24-pin connector of your power supply, so that your power supply gives power to the pump but does not give power anywhere else. One more thing that you have to remember while doing all of this is, when you're assembling the PC back again, if it was a pre-built, make sure to wipe off all existing residue of the thermal paste that you would have on your processor or even your GPU. You can use isopropyl alcohol, 99% is available easily on Amazon. Use probably microfiber cloth, or in fact a cotton bud as well. You can use that. I would prefer microfiber cloth because it does not leave any residue back. And then use a good thermal paste again while reattaching everything. I use Thermal Grizzly's Cryonaut grease paste. It had good reviews. I've been following it for quite some time, and now that I have used it for around a month or so, it's quite good.